literally broke right now. So I don't have any money. So I can't buy Screencastify right now. So, broke. Anyway, you have to write this down. All right, and then so I will be honest, but then for you it's a lie, but it's honest. Last hour, I kind of scanned the notes beforehand, but I didn't do any. I kind of thought a little bit, and then a couple of them I was like, "Ooh, man, these are kind of like tougher." Um, and I will officially struggle in front of the students on purpose as well, because these can be a struggle. That's why I yelled at him over there. Their pen does not work. If you use a pen on this, just get ready to probably get a 50%. You'll be lucky to get a 50, because there is going to be a lot of writes and rewrites. And if I see a bunch of scratch outs and it looks like just a trash heap, I'm not grading it. Not doing it. No other teacher would either. So we got to have a pencil. We got to be ready for little mistakes. This is it can be rough, but many of you said you were okay yesterday, right? So hopefully we did well here. All right. So I'm also blabbering because you have to do old school notes and write these down yourself. Remember, we're going straight down. So our order goes step, 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 like a geometry proof. At least hopefully you remember that structure. Anyone that snakes their work, if I can't get the logic of your progression, I'm not wasting my time, because everyone should be able to do the same thing. Everyone should be able to do step one and put it right here, and then step two is right below that, and so on and so on and so forth. And then also, who's more complicated? I don't know if I threw this out. Left or right? Come on, left. I can't. I probably could not have the imagination to turn the right side into to the left. It's really tough to expand. It's easy to condense and simplify. I probably could, but it would take 3 times as long and probably more mistakes. Like I said, erasing. Because I could see what I would want to do. I mean, I know what I would. What do you think I do up in the top? Good foiler, say it. Factor was the thing there that I didn't get from people. And you should know a difference of 2 squares. And the reason I like that is I know something's going to simplify right away. I'm a good factor, which makes me a what? Good foiler. Okay. Whole point of that, I'll factor then check. I don't need to check them. I'm a master at difference of 2 squares. And then I notice this. Okay, I have a minus sign. I do have a minus sign there, so that these are probably going to match. But these are sine and cosine. That's going to be a little rough. So I'll wait. Oh, but I already knew. What's the next thing that's going to change? What's the next thing that's going to change? This is 1. So I do want to see this. And I think I did write that last hour. I didn't change it above it. I wonder if the other 2 teachers would allow it to change this above right there. I don't like that. I think we should spend a moment to prove, because what are you proving? You're proving, believe me, this could be worse. You're proving that this changes into this. I don't need a highlighter, so you don't need to grab them. Okay, but when I look at your logical steps, I can logically see your changes, and that's a logical change. That is a valid substitution. No highlighting needed. It used to be, I never liked this, the other teachers used to make students write reasons why. And then you'd have to write over here, I did this because cosine squared plus sine squared equals 1. They'd have to write that wording out. Do you want to do that? Or do you want to just logically write your steps one at a time? Okay, I think that's a good deal. Because I need to be the grader. You need to make sure I can understand what you are writing. That is your job, and only your job. Now, this is weird. This is weird. I think this happened yesterday. So I'm looking over there on the right side. I can't when I have it cut off, so it's hard to kind of do there. And I have a minus sign, and I have this minus sign here, but I don't have this denominator. Okay, I got it. What I could do is reverse the common denominator. That's what's weird. You have to do this a lot in identity solving. Reversing the common denominator rule. That's what I kind of say this process is. So we reverse And now I got a big fat minus sign separating two terms. Oh, and then I already see what's going to, I'm good to go. So I'll be able to do this in one more step. So that is a big step. Understanding, and why do I call it reversing? Because when I have a common denominator and I subtract, I put them underneath a common denominator. That means I could reverse it and separate this into two fractions with that common denominator. And you better get that locked in. Too many people don't listen to me while I'm doing notes. They're like, where did I get that from? All right, now what am I going to do here? What am I going to do here? That can cancel now, and that can cancel, and then we can write what's 1 over sine squared? Cosecant squared. And remember the rule. You do not, guess what? Here's 1 point off if you do this. You're gone. The final answer is always writing what the right side is. But logically, your step before it proves that that is true. Any skip step in between, you're not proving anything. Okay? So that's how we always end, and that takes care of a lot of business. That takes care of a lot of other things that would probably be worse for you as far as what you have to write as a student. Now, I will be honest, but I did do this last hour, and it worked, my setup. I think it's the next one I'm talking about. I do like having my face there just because, just so you know, I'm doing this live in a classroom. I will be honest, this one, I didn't know which side to work on. As a matter of fact, I was hoping last hour I worked on one side, and I was hoping the key worked on the other side. Because you probably could. But here's why I went with the right side this time. Because I thought a couple steps ahead of time. What do you think I'm going to do on the right side? And it has something to do with this. What do you think I'm going to do? I'm going to multiply top and bottom by something. What do you think it's going to be? 1 minus cosine, what I call the conjugate, which it really can be called the conjugate. Remember, I got to talk in here because WeVideo won't let me have my headphones with my microphone. I can't wait till I'm done with you. Maybe this is why the WeVideo doesn't work. They listen to me on the scenes and hear me rip on them. But anyway, and then you know what that introduces? A minus sign, right? And then what happens when I do 1 minus cosine theta and multiply by 1 plus cosine theta? I get 1 minus cosine squared, which is what? Sine squared. And then I have a 1 minus cosine in the top. I have a minus. I'm feeling good about this process. So now let's actually write it if you were not focused in what I'm saying. Okay. So now I have to write an equals here because I'm working on the right side. And you know what? Lies. I allowed you to do this as well. I allowed you to do step 1, inserting it right in the question. Now I know you don't have a printed worksheet. Sorry, that's a cosine. But imagine on a test, you have it printed in front of you. And you will. This cannot be multiple choice. This is the written part. All right. You have to show all your steps. But you're allowed to insert it in, like right in the question. And then I need this. Now, I know what the future is going to be. So I know I don't want to distribute the numerator. Because I know this is going to turn into sine squared, and I know I'm probably going to want to cancel. But don't do that. You must prove that you know how to FOIL. That's proof that you know how to FOIL. You show me you know how to FOIL. And then proof that you know a Pythagorean identity. Now, I know last hour I did this. I wrote, say you did, and you do have to have them memorized. You're not getting them anymore. Our last test was about solving. It wasn't about knowing your identities. Now you need to know them. You're not getting an identity sheet. All right, but here's what I did last hour. X squared plus y squared equals r squared. Write that down if you can't remember them. And then this one is when you divide by r squared. Okay? But what I want to know is how come I know 1 minus cosine squared is sine squared? Because this is cosine squared plus sine squared equals 1. And then I could subtract that cosine squared from both sides. And that's how I get sine squared by itself. I'm not explaining that anymore. You need to get on board with that, and you need to understand these replacements. Okay? You need to. Sometimes the Pythagorean identities are the worst. Now, I do like this, and I do allow this. This is cancel and cancel one of those squares. Okay? And now I'm feeling real good. Because what's cosecant? What's cosecant? So maybe one more step, although this I could maybe see. I wouldn't be mad if you, but it kind of is. It kind of is a step because this is the separation of a common denominator, or the reverse of the common denominator rule. So I think I do kind of need that step. I would be shaking with my red pen if you skip this middle step here. If you skip step 3, I'd be like, oh, I feel like at least a half point because I feel like they're cutting corners on me when I could have made this a lot worse. Explain every step and write sentences. Okay, so yeah. But that's all good logic there. All good logic. So it worked out pretty well. Then when I looked at the key for the other 2 teachers, they did the same thing. Someone asked me last hour, can I have more than your steps there? What do you think? Yes or no? Yeah, those are logical. Even if it's a step that didn't really take you anywhere, but it's not wrong, then fine. I don't care what anyone says about me. I don't care. I know some don't like me, but at least you got to admit what I try to teach to you is the most efficient way of doing stuff. You do agree with that, don't you? Okay, and I try to make that attempt all the way through. Every time I think about it, how could this be the easiest for the kids? Young adults. Okay, now I do have to pause and give them a chance to write because we're doing an old school night way back in 2016. Oh, there were students back then? Wow. Oh, you guys were alive. What grade were you in 2016? 3rd? Oh my gosh, so funny. Oh. Before COVID, you liked your teachers, you liked teaching, you liked school. Wait, what grade are we in? 16? 2016? We're still fighting over this? Second or third? This is 15, 16. This is the 15, 16 school year, so. Third? No, they're saying second grade. You think it's second? Does this have to be on the notes? Does he have a pen or a pencil? Random out. Does he have a pencil? All right, here we go. Now look, my first inclination was when I looked at this, and actually I looked at it 3rd hour, and then I purposely said I'm not going to do it. I'm gonna fumble in front of the other 4th hour, but I already did it. And the first thing I thought was same thing. Anyone? Conjugate. You know why I don't want to do that? And I thought it was terrible. Tan and cotan do not connect in a anyone Pythagorean identity. They're not connected. They're not in the Pythagorean identity. My first instinct was that, but I'm like, wait a minute, that won't reduce or simplify. Then the other problem is, say what that is. What is that trig? Sine. Are any of these sine? So then the next thing I said is, we know the left side's more complicated. The next thing is, well, then let's change everything in terms of sine and cosine. And then at least I've done that. I got at least, there's some signs in here. And then I'm going to be a little short on room here. That's sine. And oh my gosh, the things that'll happen. And I do have to say with the ABers, this is by the way, we do keep it short. We're going beyond what the AP exam will ask on identities. They'll keep it real simple. But we got to have you ready for calculus. Either AB or BC, both are awesome. Whichever one you signed up for. And if you didn't, stats, that's good too. But just saying, we got to get you ready for this. This is kind of, I think right now, trig is all over the place in calculus. I got a girl that comes into tutoring. I can't help her. She just likes coming into tutoring and writing stuff on the board. I'm like, that looks great. I don't even understand what I'm looking at. But I do see a lot of trig in it. You got to know your trig. So that's why we have to go beyond what the AP is asking. All right, but anyway, I don't want to get a common denominator. Because then I still have fractions within fractions. You've actually been taught this, complex fractions. What I can do is multiply the top and bottom by something that'll get rid of all these little fractions. And it really is just multiplying by the common denominator of all these little denominators. And what did I do a mistake? Oh, I wasn't finished yet. So impatient. What would I multiply top and bottom by then? Cosine, sine. And then I swear to dog, you better be this good. Because I just the fractions, and this is not a hard concept. It isn't. It just makes me cry. It makes Mr. Bean cry. How the physics students can't deal with a fraction. This gets distributed into the numerator. And there's a reason why you pick this. Canceling. So who cancels when I throw that blue cosine u sine u? Cosine. And what are you left with? Tell me. Sine squared. I want us all to be able to do that logically and me understand your logical step. And I want everyone to be able to know that this gets distributed here into the numerator, and who cancels? Sine. And what are you left with? Cosine squared. Oh, and then the bottom's going to be beautiful. I'm already thinking ahead. Because the bottom, same thing. Who cancels? Say it. Cosine. And who cancels in the next one? Let's speed this up. I do have to go a little slow because they have to write the notes down too, then do the notes. And I didn't give them a printout. Someone started calling their lawyer. What? No printout. Not fair. Okay, remember put equals. So really putting someone to sleep back there. Same kid every day. All right. What's sine squared plus cosine squared, everyone? 1. So I am at, wait, now what do we have over here? Oh, there's something else. I did this last hour as well. You know what was going to happen? If I kept going, I was not going to match the right side. Like, what did I do wrong? What am I doing wrong? What did I miss? +1. So what would have happened? This is about the same time I saw a student raise their hand. And that's the same time I made the same mistake last hour. I lost the 1. But what would have happened is, wait, why don't I match the right side? Then I would have looked at +1. Then I could have inserted it and it would have worked. Okay, and then you know what you can do? What does the right side not have? Yeah, that's what I said. What does it not have that the left side has? So I'm going to do 2 steps in 1. I'm going to replace this and replace that. Rah! Another one. We got a lack of oxygen in this room. Oxygen hogs. All right, what's cosine squared? What's cosine squared? 1 minus sine squared. Humor me, write that replacement. Humor me, write that replacement. And then put the +1. I would have been off 1. I would add an extra -1 or, yeah, actually -1 floating around. So do my replacements. And why? It's because you have to keep looking at the right side. You have to make the right side happen. The right side does not have cosine squared. It has only sine squared. Okay, I know something that I can change cosine squared in terms of sine squared. Pythagorean identity. And then go ahead and do this. I'm doing this for your benefit. You don't necessarily have to. You can use your pencil, same color, and then distribute the minus sign, and then we could write the final answer here. You could do this as well. This is kind of getting a little too much in one step, but not really, because the denominator has no meaning anymore. Denominator of 1 is just that. Oh, there we go. I got it. Is that the second bell, right? Yeah, I think so. Or is it the first bell? Are the crazies out in the hallway? Oh, there's it. Okay, then this happened last hour. My arrow got a little in the way. Doink. Is that too fast? Sorry. Just leave that up there for a second. That's, what is this? Oh, that was the end of my arrow. I was like, what is that? Okay. Okay. Man, another one. Stealing oxygen over there. Okay, give you a minute. There's only 2 more. This one I wasn't worried about because usually this is the case and it usually works out. As you're writing this down, what do you think the general words would be for the process? No well, kind of, but it's really getting a common denominator, which happens that they happen to be conjugates. We're using that word liberally here. Conjugate just means one minus sign, one plus sign. Okay, those are considered conjugates of each other. I think that's for radicals. They use that term in I numbers, but you can use the same termage there. Termage, verbiage, just made up a word. Okay, then guess what? I allow you to do this even if it's squeezed in here. Getting a common denominator, this is missing a 1 plus sign. And go ahead. Go ahead and be a lazy. Oh, go ahead and be a lazy bum and not write theta. Half point off. Maybe 1 if you write it all the way through, because this is a mess. It actually looks awful. But there always has to be an argument there. I'm not being a tough guy. I'm telling you, I am shortening your requirements here. But I still have requirements. But they're actually requirements that every math teacher should have. You should never be so sloppy that you don't write theta, an argument in there. You also should not just write one of these. You have to multiply both top and bottom by this. Did I make another mistake? Go ahead. If these have theta, you should say theta. It's kind of confusing. You don't like a cracked egg? All you got to do is this and that. Come on. It's almost the same amount of, going on there. Okay. Oh, it's called The Farthest. The Voyager, remember my Voyager? This is 24 hours ago. The show is called The Farthest. It's a 2-hour show. Unfortunately, I just saw that it's only purchasable. You can, I don't see it for free anymore. So I had to see it on, but I've seen it like 3 times. I wanted to watch it last night, and I wasn't able to. Okay, sine and sine is 2 sines, and then sine squared. Know how to FOIL? I don't need parentheses for this, but I do need for this. This minus sign is minus this product. So it does have to eventually be distributed. I might be able to do it after I do this FOIL. This is, oh, this is nice. 1 times 1 is 1. I hope I didn't make a mistake on this one. Oh, I did make a mistake. You should add your hand up on that. This is 1 minus. I knew something was wrong there. Because up here, because I knew this was going to be 1 times 1. And then 1 times negative sign twice. You got an outer and an inner. Good FOILers, good factors. And negative sign multiplied together is positive. Sine squared. Teaching foiling. There's that second bell. Now, here's what I was blabbering about. This is only step 1. The purpose of getting a common denominator is to have one of these. Right? So you add the numerators, or in this case, subtract. And then put them over a common denominator. And the common denominator is just 1 minus sine squared because the middle term falls out. I said passes out because it looks like a student's about to pass out back here. Do not change that. Show me you know how to FOIL. And show me you know what a common denominator is, why we did this. But now go ahead and change it. But you know what you could do? You could go ahead and do, this is equals. You could go ahead and do the distributing of the minus sign. And then who cancels? I'm going to allow this. Who cancels? Up in the numerator, who cancels? 1. And who else cancels? Sine squared. This is totally allowable. I don't believe this deserves another written step. I firmly don't, because all you did is distribute and cancel like terms that are added together. But then move on. Once you get too many steps in one, be careful and tread lightly. 2 sine and 2 sine is all that's left over, which is 4 sine. 1 minus sine squared is cosine squared. Now, I did require my last hour to do 2 more things. Because now I'm looking at it, hey, I got the 4. I'm excited. And then I don't have it. Oh, okay, hold on a minute. I know cosine squared is cosine, cosine. I'm done with this, so I can kind of erase this. So step 3. That didn't bother you, but I want to write this as 4 sine over, and I want to write this like this to really, really make myself understand it. And really, my job is to make Mr. Samuelis understand what I'm writing. So I'm going to write cosine squared as cosine cosine. I'm going to write it like that. Hey, everybody, what's sine over cosine? Tan. Hey, everybody, you could even be real fancy. Times 1 doesn't change anything. What's 1 over cosine, everybody? Secant. You don't have to do the 1. I'm just saying, improving what happens here. When you write this like this, it looks beautiful and no one could argue. Nobody could argue your logic. Remember, that's what proving, geometric proofs. It's just a logic structure. That's why it makes me sad we don't do it as, not really. I don't really like teaching proofs. To be honest, I don't. And then this last one's easy because come on. As you're writing this down, what do you think you're going to do? As you're writing this down, what do you think the word is that we're going to do? Just one word. No. Some could argue distribute. We like the 4-letter F word. What? Foil. Not factor. This is foil. 1 minus. Come on, don't have to write this out next to each other. You take cosine times cosine, which is cosine squared. You take cosine times negative sine twice. So that's -2. I don't care if it's sine cosine or cosine sine. There's no rules on that. And then negative sine twice multiplied is positive sine squared. You know what? I'm not even going to distribute yet because I see something that's going to happen. Anyone else see what's going to happen? What am I going to replace next? What am I going to replace next? I haven't heard it yet. What is that going to become? 1. Now I can, I don't know if you just as a student not highlighted, I'm going to be okay with this. I do not want another step of using the commutative property. I think that's a little beyond a high-level math course. Meaning, let me rewrite this so cosine squared is right next to plus sine squared and then replace this with 1. I would be okay with this without the highlighting. I'm highlighting for your purposes. Okay, that is a Pythagorean identity. And then -2 sine cosine. And then over cosine. There are some math sticklers. If there are teachers watching this, nobody does. Believe me. They may say, he's just letting them get away with so much, not showing all the steps. That's another thing about geometry proofs. Depending on your teacher, some would mark you wrong in some things and others wouldn't, depending on how much you'd have to write. Okay? And then those real staunch, they'd be like, no, I'm always right. You should write every single step. Go ahead and distribute that minus sign. And then who cancels? Are you okay back there? I thought a kid's head was going to fall off. He just rolled back his eyes. I thought he was having a seizure or something. I shouldn't joke about that. Are you all right? Okay. Literally, I thought you were going to fall out of your chair. You leaned back so far. Who's that? Oh, thanks. Ferris. End of the period. Ferris. See that age kicking in? Did that on purpose. Okay, then what are we looking for? Oh, cancel. Okay. I think the last are, then write this. I don't think we have to write this. You see the canceling, you see this is all alone, and you see that's that. Fair, we were almost done with the video, and I had to do that pass thing. Okay, are we done? Are you done? You know what I said? Okay, I'll say it after the video. I don't want evidence what I say here, but there's still the people can't keep their mouths shut, and they'll tell the other